All right, the weight of a certain machined part has a standard deviation of 7 grams. How many parts from the assembly line would you need to sample in order to calculate a 95% confidence interval estimate of the average weight of the parts being manufactured with a margin of error of 3.97 grams? So it's like you're trying to figure out what the population mean of this machine part is. So you want to pull enough items off the assembly line to make sure that you can guess that mean within a certain range. So it's like you're starting with the confidence interval, saying you don't even know what the X bar is yet, but you know you want the margin of error to be 3.97 grams or less. So what we're saying then is we want our right end of the confidence interval to be X bar plus 3.97, and our left side should be X bar minus 3.97. So we want to be within 3.97 grams of our population mean. So they're saying how many items do you have to pull off the assembly line to achieve this? So the ZC for a 95% confidence interval is 1.96. Alright, so with that in mind, we'll use the formula E equals ZC sigma over square root of n. Standard deviation is given to be 7 grams. And the margin of error that's desired is 3.97 grams. And we now know the ZC that we require as well. So it's going to be this, and this that we use in our calculation. Alright, so we'll have 3.97 grams equals 1.96 times 7 grams, which is the standard deviation, over square root of n. Let's multiply that square root of n to the other side so we can get n above. Then we will divide by the 3.97. And then we'll finally just square both sides. $11.9 is what I get, but we want to round that up to 12. So you want to sample 12 items off the assembly line, get an average for them, and then we can be 95% confident. So we would be 95% confident that the true population mean for this machine part is within 3.97 grams of our sample mean the sample size is at least 12 items or 12 members of the population.